wouldn't it? Okay, so if you just joined us, because I didn't record, page 150, number 4 is finished. We could not get any critical numbers because we can't square it in a negative. The derivative is never undefined, so we have one interval that's negative infinity to positive infinity. Feel free to pause it so you can dissect the work. All right, how about number 5 on this page? Okay, yes?
If it adds a worksheet, is that just it, or do you want us to include justification for why?
Okay, it's a multiple choice.
Right. So,
No. And on the AP exam, you want to do as little as possible to get the answer because of time. Okay, yes? Uh-huh. I would suggest that you show work, and I scheduled your exams, 2nd period, 3rd period, 4th period, for a reason. That way, everybody has the big periods. So I'm going to give you the entire time. Okay? I mean, we could review if you wanted to review, or you literally can have the entire time. So, I thought that might be pleasing to you all, so that would give you more time to show work. The more work you show, the more accurate you tend to be. Just less mistakes that tend to be made. But I will not be grading your work. I will be collecting your work, but I will not be grading it. Now, when it comes to the free response, then there's partial credit. So you better show me the work. All right, number 5. Do you all need to see number 5? Okay. So they want the derivative at 1. So this is same page, number 5. We have a piecewise function, which the College Board is in love with recently. So I want you to get over the, what do we want to say, the anxiety caused by piecewise functions. We need that to go. All right, this is what they've asked for. So you tell me, and this is saying a lot, what is this telling us to do? That first it's telling us to find the derivative. And then what is it telling us to do? Substitute in. So do you see why we use symbolism? We'd have to write about a big long sentence to say that. That's why math is wonderful. All right, so here we go. How do you do the derivative of a piecewise function? You do the derivative of each piece, right? X is less than or equal to 1, x is greater than 1. Now, we have to find the function. Which function do we use for 1? How do you know it's the top one? Because of the equal to. So that means it's going to be 2 times 1 or 2. Not bad? So now we're going to go to page 160. And the only one I've asked for on 160 is number 25. Want to see it? Okay. These type of problems can assess an awful lot of stuff. First of all, they're telling us, so this is page 160, and this is number 25. First of all, they're using the word continuous. What does that mean? No asymptotes, no holes, no breaks. And it's continuous on this closed interval AB. All right. So we've got continuous on a closed interval. Which of the following statements are not necessarily true? All right, so continuous on a closed interval should jog your memories for all the theorems, all right? We started with intermediate value theorem, then we went to extreme value theorem, and then we went to mean value theorem. Which is the only one that involves a derivative? Mean value theorem is slope of secant, which is algebra 1 slope, equals slope of tangent. Okay? That's the only one that involves the derivative. So, number 3 talks about a derivative. So that could be a possibility. What does EVT talk about? Extrema. What kind of extrema? Absolute extrema. And if it's continuous, and if it's on a closed interval, do all 3 of these require those conditions? Yes. Are we guaranteed absolute extrema for extreme value theorem? For extreme value theorem, we are. Intermediate value theorem, Just tells us that there's a y between two x's. If the given y value falls between. So, part 1 says f has a minimum on that closed interval. True or false? True. Part 2 says f has a maximum. True or false? Which one is that? Which theorem? Both of them, correct? Both of these are extreme value theorem. Now let's look at the third. The third says that f prime of c equals 0. Okay? And they're telling us that for some number in the interval a to b, that there's going to be a c inside here where the derivative has to be 0. Just because a function is continuous on a closed interval, are we guaranteed a derivative to be 0? No. So what is the answer? 1 and 2, which would be D. Oh, make sure you read the question. They want not true. So not true would be C. All right, so that's 160. Let's go on to 169.
If you haven't shown
No, because the extrema can occur at an endpoint on the absolute value. On the absolute or in the extreme value theorem. Remember, the extreme value theorem, they either occur at the endpoints or the critical numbers. And even if it was just critical numbers, they could be both sharp turns. Okay? So we're on page 169. We are doing number 43. And do you need this one? Okay. So I'm going to go to a new page. Again, lots of concepts on this. Page 169, this is number 43. All right, it says, let f of x be differentiable. So we're going to stop right there. The biggest thing I could help you with right now is reading the question. We're going to stop right here. What does this word differentiable mean? Okay. It's continuous. All right, that means there's no breaks, jump, gaps. And what else? No asymptotes because it's continuous. No holes because it's continuous. No breaks. What else? Right. What is not here? It's differentiable. So because it's continuous, the issue with derivatives that asymptotes, holes, and breaks are gone. But what is still an issue with a continuous graph? Sharp turns. In other words, there are no sharp turns. Does that make sense? Differentiable, continuous, derivative exists everywhere, no sharp turns. All right, then it says, is defined for all real numbers. The table below gives the value of f of x and its derivative for selected values of x. All right, did you all bring your book? Most of you, do you at least have one to look on? Because that way I won't rewrite the table. So let's look at what the first thing they're saying. The first thing they're saying is at x equal 2, the function is increasing. F of x, function's increasing. All right, don't look at your table. For the function to be increasing, what do you have to look at? First derivative, positive. So let's look at 2. Let's look, what is its first derivative? It is positive. Is this true? Yes. So I try not to look until I say, okay, what do I know about increasing? All right, number 2. It says there is a relative minimum on the interval, relative minimum, on the interval -1 to x to 1. But not necessarily at x equals 0. Is there a minimum? How do we know if there's a minimum? If the second, but we don't have any information on the second derivative. If the first derivative equals 0, what is the y value at -1? -2. What is the x value at 1? 2. So I can't use mean value theorem because these numbers aren't the same. But what is happening from negative 1 to 2? There's this, when the first derivative changes signs, right? Now, the first derivative changed signs, and we know it's differentiable, and we know it's continuous. So is there going to be a relative minimum? Yes. Does it have to be at x equals 0? Not necessarily. Could x equals 0 be a maximum? Because what's happening? You only know what's going on at negative 1, at 0, and what, 1. Lots of things could be occurring in between here, and lots of things could be occurring in between there. You could have a function come up and go down and go up and go down and go up, all in that little tiny space. You with me? So this one is also true. There is a relative. The fact that it said relative, I'm going to say no. If they had said absolute, then it would have been yes. Okay, so now it says there's a relative maximum in the interval negative 1 to 1. Now, what did they tell us on here? We know f of 0. So let's look at our y values. If we look at our y values, we've got negative 1, 0. Then we've got 0, 1. And then we've got 1, 0. So what are we doing from negative 1 to 1? Increasing. What are we doing from 1 to 0? Decreasing somewhere in there. They're saying there's a relative maximum. Is there? There should be, and because a derivative does change signs, doesn't mean it's happening at 0, but there's going to be a relative maximum. So I believe the answer is E, 1, 2, and 3. Was it E? All right, so now we're going to go to page 170. Which one? 44. Particle moves along the x-axis, and they gave us position, and they want velocity. What do you know about the relationship to position and velocity? First derivative. So this is number 44, page 170. We've got position, and we've got velocity. And velocity is the derivative of position. Do you remember that? Okay. I'm going to go back and read. It moves, and now, right now I'm working on your AP exam, okay? You need to understand the motion. What did they say it's doing? It's moving along the what? So there's this particle that's moving along the x-axis, back and forth. So its position at any time where t is greater than 0, we're not going to go into negative time, is given by this function. Oh, maybe this was a calculator problem, and I didn't see the cosine. Equals t cubed plus 22t minus, plus 3 minus 6 cosine pi t. I think this is a calculator problem. Sorry. But the concept's still there. For what value of t, if any, is the velocity negative? What do you have to do? Take the first derivative. So our first derivative is going to be 3t squared plus 22t. Do you agree 3's gone? Derivative of cosine is negative sine. Yeah, did I mess it up? Yeah. Thank you. So now, tell me if I'm doing this one right. I've got cosine is negative sine, so that makes it positive. And is this chain rule? Yes. Okay. So there's no way we're going to be able to solve this with the methods that we have, which means that this is definitely a what? Calculator problem. There it is. Hold on. Make sure I have the mouse. There we go. So we're going to do a new one. We're going to do that one, and we're going to go, and I need to see the calculator on top. Okay, so here we go. So we are going to substitute this into y equals. maybe. We're going to say 3, and I like to think of the x button as variable, not just x squared plus 22 plus 6, and that's going to be sine. Oh, I needed a pi. I'll do that at the end. I'm going to do pi variable, close the parenthesis, and then I'll multiply by the pi that I forgot about. Oh. I need pi. Did I not get the second? There we go. And we're going to graph. Oh my, I can't see anything. What are they asking us? For greater than 0. All right, so let's change our window. I am going to go maybe to 50. And do you agree we need to see more y's that are higher? So why don't we look at y's that are like 100? Wait a minute, what are they asking us? Is negative. What have we seen so far? We've only seen positives. Come on. Oh, just kidding. All right, is it ever negative? No. So was 44E? Okay, so you needed a calculator on that one. I would not put that on the exam because I'm not going to give you a calculator. All right, from here we have 203. 95, 203. Oh, what about this one? Any questions on this one? Any questions? You want to see it? Okay. So it says, note this is the graph of the second derivative. It is not the graph of the original. So the figure above shows the second derivative of a function f. F is continuous for all x's. Which of the following statements are true? They're telling us that f is concave up for x's less than 0. Okay, hold on. Before we go there, we're talking concavity. This is page 203, number 38. All right, to be concave up, what must be true? Second derivative must be what? Greater than 0. So the question is the second derivative, our graph, positive for x is less than 0? How about between b and c? So is number 1 true? Okay, so there's our first one. Now, f has a relative maximum in the open interval b to c. Remember that function's continuous, correct? So if I have an original function that has a maximum, what can you tell me about the second derivative at that maximum? What do you know about the second derivative? It has to be, okay, that would have to be concave down. F has, wait a minute, the second derivative would have to be, now I'm confused. If I do f double prime of a critical number, and it comes out positive, concave up min, right? If I do f double prime of a critical number, and it's negative, then it should be what? Concave down max. What did they say? They said there's a maximum between b and c. All right, the second derivative is always positive there, isn't it? But they said it was e. Oh, so that is wrong. I'm looking at the wrong thing. So, do you agree why that can't be? All right, for us to have a maximum, the second derivative must be what? Negative. And if you look at your picture, it's totally above the x-axis. All right. F has points of inflection at 0 and b. This is the second derivative. So on the second derivative, what are we looking for? Where it changes from positive to negative. And where does this change from positive? A second derivative changes signs where? It changes signs at 0 because we went from above to below, and where else? At B, because we went below to above. Is that what they said? So it's 1 and 3. All right, so that was 1.7. No, that was 203. Now we're going to go to 212, which I think might be a free response. It's the Ferris wheel problem, and we're going to do A and B. So we're going to start reading. It tells us that the following table gives us the velocity. What's velocity? It's the first derivative of position. It tells us how quickly you're traveling, correct? And it tells you the direction. Agreed? Of a rider on a Ferris wheel at an amusement park. Time is measured in seconds after the ride starts. The table gives values for one complete continuous revolution. So this is one revolution. It's not more than one. During what interval of time is the acceleration negative? When is acceleration negative? When the velocity is decreasing. So look at your table. The velocity is going from 0 to 1.6. Is that increasing or decreasing? Increasing. 1.6 to 2.7? 2.7 to 3.1. So are those any good? No. Let me put up here. This is page 212 before I forget number 3A. All right. So now we're going from 1.3 to what? 2.7. So we start decreasing at 15. 2.7 to 1.6, 1.6 to 0 to negative 1.6 to negative 1 or 2.7 to negative 3.1, and then what? So from 15 to 45 on that interval. What did they say? During what time interval is the acceleration negative? Did I give you any of those answers? I didn't, did I? It's negative on the interval 15 to 45. And that, give a reason for your answer. Because would the second derivative be negative if we did the slope? Yep, because the second derivative is negative. Because if you did 3.1 minus 2.7 over 5, it would be negative. No. If we did 2.7 minus 3.1 over 20 minus 15, it would be negative. Part B, what is the average acceleration during the first 15 seconds? What's the relationship of acceleration to velocity? Acceleration is the second derivative of position or first derivative of velocity. So what are they asking for if they want the acceleration? And remember they said average, keyword. What are they looking for? Algebra 1 slope. What's your first ordered pair? 0, 0. What's your second ordered pair? Okay, how did you figure out it was those two? First 15 seconds. Oh, that's pretty easy. 3.1 minus 0 over, was it 3.1? Over 15 minus 0, which is 3.1 divided by 15, and that is what? Units. Acceleration. Feet per second squared. Now, if this were a free response, can you leave your answer just like that? Yes. You will get credit on the AP exam for that. In fact, you would have already gotten the credit here. Why do you want to stop here? And make it, in case you make a dumb mistake, yes. So I will grade your exam appropriately, the same way. So, any questions on those? Yes.
What was the justification
For 3A, because the second derivative was negative. The first derivative?
How can you justify that the acceleration is negative if the derivative is negative into the velocity?
But is that calculus? They want to know when is acceleration negative. That would be for the one above it, not the one below it. When the first derivative is decreasing, the position then. Oh, wait a minute. If the first derivative, if velocity is decreasing, that means second derivative is negative.
So if acceleration is the second derivative.
So,
We just had velocity.
The first, I said that's the loss. She said it has to be. Do you want to base it off of acceleration because it's the second derivative? Or the first derivative?
first derivative is negative? No, it's decreasing. I'll accept either. Okay? Velocity is decreasing or second derivative is or acceleration is negative. That's what they're asking though, isn't it? So it's probably a better explanation. Or you could say that, okay. All right, so let's go to page 216. That's another one. Oh, this is a parameter. I had lots of these to choose from for your free responses from several years ago. All right, what are we given? This is page 216, number 5, and we're doing A through C. All right, first of all, we're given a function, and it's some parameter, unknown constant, minus 7x squared, and this is for all a greater than 0. You want to join us?
Yeah.
Yeah. Abinu is going to move his stuff so you can. All right. You ready? It says find in terms of A. What does in terms of A mean? A will be in your answer. You will not get a number. The equation of the line tangent to these curves at x equal 1. We want an equation of a tangent line. What two things do we need? A point and slope. What have they given us? A half a point. We need the other half of the point. How do we get the other half of the point? We're going to say f of negative 1 is equal to a times 7 minus, now that negative 1's being squared. If you put parentheses around it, you'll avoid making the careless. You can't change this to addition. The exponent be 4. If you don't put parentheses around that, you're going to do plus plus, and it's going to mess it up. So that's going to be 7 minus 1, which is what? 6 what? A. So that's your point, 1, 6a. Now, how do we get slope? First derivative. All right, so do I have to do the product rule? Are there variables on both sides? No. So we're going to say a times the derivative of 7 is 0, and the derivative of x squared is 2x. In other words, it's going to be negative 2xa. So now how do I get the derivative specifically at 1? Some of you all stop short and stop here. What's the derivative at 1? At negative 1, just kidding. It's going to be negative 2 times what? Which is what? 2a. So how do we write the equation of our line? It's going to be y minus the y value is equal to our slope times x minus the x value. And why do we stop here? Because if you make a mistake, you lose the point you just gained. Part B again says, find in the terms of A. What does that mean? A will be in the answer, and that always gets you frustrated and always makes you nervous when you can't get rid of the A. They want the y-intercept of the tangent line. Well, great. How do we get a y-intercept? A y-intercept, we put 0 in for x. So B would be y, oh, I don't know why I did that. B would be y minus 6a times 2a. All right, hold on. I need an equal sign. Equals 2a times 0 plus 1. Or y minus 6a is equal to 2a. Or y equals 2a minus plus 6a, which means y equals what? 8a. So we could have stayed up here And we could have said, well, that's going to be 2ax plus 2a. What form am I putting this in? Slope, intercept form. So you could have done this also, and now where's your y-intercept in that form? Does it match? Okay. Let's see. I have to do C. Find the x-intercept. Now what do we do? This is D. How do you get an x-intercept? You set y equal to 0. So now we're going to put 0 in for y, in other words. So 0 is going to equal 2, I'm going to go with my slope-intercept here, plus 8a. So I'm going to subtract 8a. And then what do I do to solve for x? What we're going to do? Divide, so we end up with -4. So the x-intercept would be -4, 0. The y-intercept would be 0, 8a. That wasn't too bad. I had about 3 or 4 of these were free responses that I could choose from. Slope-intercept form, what I did is I took this blue, actually I took this red and I distributed. You with me? That's how I got those two. And then I added 6a to the other side. So I get y by itself. Okay. Now we're going to go to the textbook. We're almost finished, and then we can go back and answer any questions you want. So now we're going to go to the textbook, and it is page 104. Curious to see what I put on here. Number 33. Ah. Do you want to see in 104, page 33? Okay. So we've got, this is the book now. This is page 104, number 33. We have a function that's x squared. And we have a line, which is 2x minus y plus 1 equals 0. Find an equation of the line that is tangent to the graph of f. And we want the tangent line. We need tangent line parallel to that. Do I know in order to write the equation of the tangent line, what 2 things do I need? A point and, do I know either one? In this case, I'm going to go for, this is the tangent line, I'm going to go for what kind of slope? Parallel slope. You with me? So how do I find the slope of this line? What do we do? Move y over. Is that slope-intercept form? What's the slope? 2. What's the parallel slope? 2. What's the perpendicular slope? -1/2. So what slope am I using for my equation over here? 2. Right. So I still need a point, and that doesn't tell me where that's happening, does it? So if I come over here and I do my derivative, what is the derivative? 2x. What is the derivative that we're working with? What is the derivative? What is a derivative? Slope generating function, right? What is the slope of the tangent line? 2. So this is slope. So I'm going to put this, my parallel slope in. 2 equals 2x. So what does x equal? 1. I have half a point. How do I get my other point, or other side? Plug it in where? Into the original, which is my y generating function. So now we're going to do f of 1, which is 1 squared, or 1. Now how do you write the equation of the tangent line? Y minus, which one? The first one or the second one? Second one is equal to 2 times x minus 1. And this is, that would suffice. Take a break. I heard yes. If there's one yes, we do it. All right. Number 117 is about acceleration. So this is book again. This is page 129, number 117. Okay, so we have velocity of an object is v of t. 36 minus, yes I am. Look. Because I left it up so I'd see the little red dot. Okay, that is velocity. It happens between 0 and 6, and I guess I really should do brackets because there's the inequality sign. Find the velocity and acceleration of the object when t equals 3. Well, can we do that right now? At least for velocity? 36 minus 3 times 3 is 9, which is 25? Maybe? Gosh darn it. Figured that was too easy. Okay, so that's 27, what? Meters per second. How am I going to get acceleration at that? So that's going to be negative 2t, so the acceleration at 3 is going to be negative 6 what? Meters per second squared. All right, there's a negative. All right. Now it says, what can be said about the speed of the object? Oh, when the acceleration and velocity have opposite signs. We've never talked about this. What do you know? Velocity and acceleration have opposite signs. Okay, let's say this is my, what do I want to call this? Position curve. Do you agree that the slope is what? Well, the slope is positive, correct? In other words, the velocity is positive. Yes? But what can you tell me about the velocity? Is it getting bigger or is it getting smaller? So what can you tell me about the acceleration then? That it is negative. It's opposite in sign. Correct? And what are we doing? Slowing down. All right. So if I'm looking at this, what is my velocity now? Negative. All right. And what are my velocities doing? Are they getting bigger or smaller? They're getting steeper, aren't they? Okay. Now, once I go past the point of inflection, is my velocity still negative? Okay. But what is my acceleration? My velocity is negative. My acceleration is negative. Wait a minute. This is where velocity is negative. This is where acceleration is negative. How do we know acceleration is negative? Anyway, when they're opposite in signs, you are slowing down. When they're same signs, you are speeding up, and it has everything to do with concavity. All right, how about the curve sketch worksheet? Do we need to go there? Okay, so here's the deal. And I will have a nice big worksheet on this second semester. When the velocity and acceleration are same signs, that means positive, positive, negative, negative. That means that the speed, the absolute value of velocity, is getting faster. Doesn't that make sense? When you accelerate, they have to be the same sign. So this is horizontally. When the velocity and acceleration are opposite in sign, then that means the speed is slowing down. All right, so maybe let's try it. When we have a positive velocity and a negative acceleration, do you agree that is happening on an increasing part of a concave down curve? So as my velocity is increasing, what is my acceleration doing? The slopes are going to 0, slowing down. All right, when you have velocity to be negative and acceleration to be positive, that means we're decreasing on a concave what? Decreasing concave up. So this is the decreasing. Do you see how steep these velocities are, and what are they doing? They are going to zero, meaning the speed is going to zero. You're slowing down. All right, does that help? All right, so you don't want the AP style curve sketch worksheet. Oh, how about the intermediate value, IVT, and average rate of change tabular form? You just had a quiz on that.
You got it turned on.
You do?
My hair progress.
Okay, so now I'm going to open the floor, and you can do popcorn questions about anything you want to see on this review because we covered it in A12 block that's already online. You with me? Okay, so I can put the book away because we're done with the book. Yes. Okay, we're on page 121, maybe, I can find it. 121, we want number 20. I don't think there is any work. Oh, did I say work? Oh. F is a function that's differentiable. What does differentiable mean? Continuous. Derivative exists, meaning there are no sharp turns. This is 20, page 121. No sharp turns. No sharp turns in continuous. All right. On the open interval, if F has a relative minimum, so we're saying phi F of C is a relative minimum. What does that mean? What does that make C? C is a, what kind of number? Critical number. What's a critical number? That's where the first derivative equals 0 or first derivative undefined. Now, I have no clue what this is asking, but you see how I'm reading the question and asking myself, what do I know? It says C must be between A and B, which means C isn't A and C isn't B. Which of the following must be true? They're telling us that F prime of C is equal to 0. Is that going to be true or false? It's a critical number, which means it's going to be true. All right. F double prime of C must exist. What did they tell us was continuous and differentiable? The function, right? So if the function's differentiable, that means its first derivative exists. Does the differentiability of a function go to the second, the third, the fourth, the fifth derivatives?
Do we want to set up a printer with this?
Why?
I have no idea, but apparently you can. That's what the second Ethernet port is for.
Oh.
One goes to the computer, the other one goes to the printer.
Do you think it prints the results?
I have no idea.
Okay. Well, if you're going to, and see, we don't have any divisions, and I don't know what division numbers they've done. But we can't, I don't think we can do the Mighty Mu test set up. I think we have to open up a new competition to do that, or else we might mess up our, you know what I'm talking about? It'd be like our competition already happened.
Right. I can do that, that's no problem.
Okay. So, you know, I don't know what they did for division.
You can always tell it what divisions should be.
I think they've already told it. I think that's the problem. All right, she got everything ready. Hold on, what's next? All right, so does the differentiability of the original tell me anything about the second derivative? No, only the first. So they're saying that F double prime of C must exist. True or false? We don't know. And because it's not an absolute yes all the time, we cannot say, so we can't include it. Now it says, if F double prime of C exists, the derivative exists, then they're telling us that the second derivative at C has got to be positive. What says it has to be positive? Okay, so because we know it's a minimum and the second derivative is When the second derivative of a critical number is positive, we know it's a what? Minimum. What are the possibilities? The second derivative of c could be greater than 0. The second derivative of c could be equal to 0. The second derivative of c could be less than 0. Do you agree those are the three possibilities? How do we know it's not this? Because we know it's a minimum. However, does the second derivative test fail when the critical number equals 0? And then you have to go back to your increasing decreasing chart to make that decision. Is it guaranteed that this is always going to be greater than 0, or is it possible that it could have failed that test and still be a minimum from the first derivative? Yes. So that means we cannot conclude 3, because the second derivative could have been 0.
So there's no like actual word to that.
Right. So that means that 1 is, or A is the only one. It was over there on the counter. Okay. So now what's next? I saw hands. Let's go on this side of the room. No problem. Morgan. Page 124, number 20. Oh, I love these. I am so glad you asked for this. I gave you quite a few of these too, didn't I? This is page 124, number 26. And I'm telling you right now, this is one of the replacements. I was so excited I could actually use it, and that because it wasn't in the original. Did you need me?
No,
Okay.
seeing what the problem was.
Oh.
Not that bad.
So, first of all, they have limit of tan 2 times x plus h minus tan of 2x, oops, there's a n, all over h as h approaches 0. Now, what is this? Exactly, it's the definition of derivative. So basically, what are they telling you to do? Take or find the what? The derivative. You with me? That is what they're asking us to do. All right. But we can't take or find the derivative unless we know the what? The original function, which I had you practice over and over and over again. What do we replace this with? X. So what is my function? Tan 2x. You see, I personally would not want to try to do this. So what I'm going to do is I'm going to say, okay, how do we do the derivative now of 2x? What's the derivative of tan? You are going to study these, correct? And you're going to make sure that you know your derivatives of your trig functions. Yes, Mrs. Bride. And then is that good enough? Because you have to do the derivative of the... By the way, if you forgot the inside, did they have that nice little answer there for you? They did, didn't they? The AP test writers are good test writers. Okay. Probably not. You were talking calc people that have to do this one. Calc people have to do this one. And the SAT writers don't have to be that high in math.
They love that limit thingy.
They do. They love that limit thingy. And I've assigned at least 3 of them in this review, I do believe. Okay, next. Surely there's more questions that you have. We've got another half an hour. Avenue. 117, number 12. Okay, we're going backwards here. Hold on. Okay, 117, number 12. Okay. This is page 117, number 12. So just looking at this picture, and I might be totally wrong, okay? I might be totally wrong. But when I see this type of picture, I can see myself connecting these 2 points, and this screams to me mean value theorem. All right? They've given us negative 3, 4, and they've given us 7, 2. With me? Arjun, please tell me you're not messing with our competition. No. Okay, no, we can't.
Oh, sorry, should sneak a new one?
So we're going to close this out. We're going to close that out. No, we can't mess with this one.
Oh, I thought they made this one for us.
For our competition, not for us to play with.
Oh, okay.
So
I don't want one to play with.
we're going to go to scan, And what, I don't know what that says.
That's his test.
So there's Mighty Mu, new computer test. So this is what we're going to do. I think we should do, oh, wait a minute. Just kidding. We're going to open it, yeah,
Call it test.
there you go. Now you have to import the names. And the import,
I just wanted to get it to
okay,
scans.
the imports and downloads. Our schools, the information should be in downloads. Okay, so now we're at page 117. Let's read the problem. The graph of y equals f of x on the closed interval. Do we need a closed interval for mean value theorem? Yes, we do. It's shown in the figure. If f is, oh my goodness, they told us it was continuous. Is that important on the closed? What is it supposed to be for differentiable? On the open interval, did they tell us it was differentiable on the open? Oh my, they did, didn't they? And then they said, then there exists a c between -3 and 7 such that, okay, so what do we know? Let's don't look at your answers. Let's just focus up here. What is this for sure? What is this for sure? Mean value theorem. What does mean value theorem say? Slope of the secant equals slope of the tangent. So don't look at your answers. What we're doing is we're going in your brains, we're going into your file cabinet that says a folder or drawer that says calculus, and we're pulling out the files that we need. Okay? We want to have all our files at our workspace before we go and start our work. Otherwise, it takes us longer. So what is slope of secant? Change in y over change in x, also known as algebra 1 slope. What is slope of tangent? First derivative. Okay. So it says, they're telling us on A that f of c equals 0. Does that have anything to do with mean value? Well, what is the slope of the secant line, by the way? Let's go ahead and find slope of secant. What is it? -2 minus +2 minus 4 over 7 minus a minus 3. Do you agree that's -2 over 10 or -1/5? Oh, so that is the slope of the secant, correct? So is it true that the slope of the secant is -1/5? What does that make also equal to -1/5? And what is the slope of the tangent? It's f prime of c. So which one is it? B. Sometimes I think it's important that you cover up the answers, you look at the picture, you look at the question, you say, what do I know about it? Because I think sometimes you see the answers and then you panic and all of a sudden now you've put up a block. You've like locked the door to the file cabinet or locked the file cabinet and lost the key. Okay, we don't want to do that. All right, Morgan? 41, number 7. Oh, another one of those. This is harder than the last one. Okay, we've got number 7. This is the limit of the absolute value of x plus h minus the absolute value of x all over h as h approaches 0. And they're saying at x equals 3. So before we go any further, what are they asking us for? Michelle? They're asking us to find the, pardon? It's like the other one, find the derivative, but it's gone a little bit further. Not just the derivative, but at x equals 3. That's what they're asking us. So what does that, so I need to find the derivative, but what do I need first? My original function. And what do? Every place we see x plus h, we replace with what? A big fat x. So what is the function? Absolute value of x. Now, we can't do that right now because it's an absolute value form. So we're going to rewrite this as a piecewise function. So this is going to be x and minus x. Set x equal to 0. Which side of 0 keeps the top positive? Greater than. Which one keeps the bottom positive? Less than. Doesn't matter where we put our equal sign. So are we ready now to do the derivative? What is the derivative of the top? and of the bottom. Now, this is for x's greater than or equal to 0. These are for x's that are less than 0. I want it at 3. Am I using the top derivative or the bottom derivative? I'm using the top derivative because 3 is bigger than 0. So what is the derivative? 1. So it was C. I like this problems. See, this is taking us one step further than I took you earlier. Yes? Uh-huh. My answer says A? Oh.
Yeah, it's a 7.
7 and 8A. This is what, page 41? Well, what happened is I guess we lost the answer for 7. Was 8A?
Yeah.
That's what happened. So 7, the answer is, does someone have a pencil? Pen. So I need to, what is this answer? I should do C, comma, A. All right. Yes, sir.
Keep saying they're basket cons.
Because we don't have divisions
I mean,
or a student number yet. We're missing 3 digits.
right, but I was trying to scan an answer key and it wouldn't even let me do that.
But I think, again, it's looking for 9 digits.
Not, shouldn't be looking for it on an answer key.
Did you mark it as a key?
Yeah, there's a function that starts scanning a key, and I ran it through that, and it thinks every answer is C, and I made every answer A. So,
Is there, but like when I do, let's go to a new page. All right, 8. This is still 41, number 8. We've got y equals x to the 4th plus bx squared plus 8x plus 1. All right. And it has a horizontal, yes, I believe I am. It has a horizontal tangent line. What does that mean? It means y prime equals 0 because what's the slope of a horizontal line? 0. And a point of inflection. It also has a point of inflection. And what's special about that point and that x value where that horizontal tangent line occurs? They're the same point. So let's start. What derivative is required for a horizontal tangent line? So y prime is equal to 4x cubed plus 2bx plus 8. And when we go to find the derivative, what are we going to do? Set the derivative equals 0, and why can't I go any further? Because I've got 2 variables. All right. How do I get a point of inflection? So now we're going to come over here and we're going to do a second derivative. What's the second derivative? 12x squared plus 2b. Now, points of inflection occur when? The second derivative equals 0. So we're going to have 12x squared plus 2b. So if I subtract 12x squared, what will I do to get my b? Divide by 2, and what will I have? Negative 6x squared. And where will I put my negative 6x squared? Into this part. So I'm going to have 2 times negative 6x squared times x plus 8. So we're going to have 0 equals 4x cubed. What happens? Negative 12x cubed plus 8. It's looking better. What's 4 and negative 12? Negative 8x cubed plus 8. How about if I add my 8x cubed? What is x cubed? What is x? 1. What did they ask for? What is the value of b? Negative 6 times 1 squared is what? Negative 6. Okay. Yes, ma'am. 52, number 29. Oh, that's an interesting one. All right, so this is page 5229. So it says, there is a function such that the limit of f of x minus f of a, does it tell me it says x minus a? It does. As x approaches a is equal to 0. First of all, before we go any further, what is this? Now, we'll recognize that. It's a what? It's a definition of, so what they're saying here is they're saying the derivative f prime of x is equal to 0, aren't they? Yes? Okay. Which of the following must be true? Well, now they're saying that the limit as, oh wait a minute, this should be a. As x approaches a of f of x does not exist. So that limit is saying that there is no y value. Is that correct? What is a limit? What are the y values doing as x approaches a certain number? Yes? How do we know that's not a derivative in purple? Because it doesn't have the f of x minus f of a, correct? So they're telling us that this y value does not exist. Can the y value not exist and the derivative exist? If the y value doesn't exist, isn't it discontinuous? If a y value does not exist, isn't the function discontinuous? This tells me that f of x is discontinuous where, specifically? At x equal a. Well, if it's discontinuous a, the derivative cannot be equal to 0. So that's not good. They're now telling us that f of a, this is the limit does not exist. Now they're telling us that f of a does not exist. If f of a does not exist, is the function continuous? Okay, let's do continuity at a point. There's 3 questions of continuity at a point. What's the first one? Let's see the hands. Everybody, is there a y? What's the second question? Is there a limit? What's the third question? Does the y equal the limit? What do we do first? Is there a y first? No. What do we do first? Is there a limit? The limit says it does not exist. If it does not exist, then it's discontinuous. If it's discontinuous, the derivative does not exist, and we know it's 0. What's the second one telling me? Is there a y? And that's saying there is not a y. If there's not a y, it's discontinuous again. So can we have a limit? I mean a derivative. No. Look at the third one. The third one is the derivative at a is equal to 0. Is this specifically the derivative at a? Yes. Here, this is, what is this saying? What's f of a? That's saying the y value is 0. Is this talking about a y value? No, it's talking about a derivative. And now they're saying f of x is continuous at x equals 0. We have no clue what's going on at 0. We don't know if a is 0. We know the derivative is 0. So what letter is it? C. See, these are deep thinking questions. These are good questions to ask. What's next? 13 on page 44. 13. Oh, what kind of derivative is this? What happened?
Try to calibrate it, but this sheet won't go through for whatever reason.
How is it not calibrated?
I guess not, because it's not recognizing anything.
Oh.
Except for answer C.
Oh.
These are too big. Calibration.
I don't know. All right. So this is asking us what's dy over dx mean? Derivative of y with respect to x. So this is 1 what? Okay. And then this is going to be 1 What rule is required on the other side? So we say first, what's the derivative of y? 1 dy over dx plus the second, which is y. What's the derivative of the first? 1 what? Dx over dx. So this becomes 1 plus dy over dx is equal to x dy over dx plus y. All right, what's the next step that we have to do? We have to get the x's and the y's on the, oh, this is where I went and looked at the answers. In A, x is positive, in B, x is positive, in C, x is positive, in D, x is positive, only in E is x negative. So I'm going to choose to move everything to this side of the equation. So I have 1, I should say my d over dx's. This is x dy over dx minus dy over dx. And what am I going to do with that y? Subtract it. So I have 1 minus y is equal to, and I'm going to factor my dy over dx, and that's going to be x minus 1. And then what are we going to do? Divide. So by looking at my answers to see who had to be positive, that way I'm assured that I'll get one of those answers, and it looks like it's C. Next. Yes.
Okay, so like, just to clarify, on number 35, on page 19.
Page 19, number 35. Yes.
Now, was the answer D? Because on the exam sheet it said D, but then I checked your A12 video and you had E, so,
Oh, did I?
well, I don't know if that's like, I suppose wrong call.
This is number 19? 19 was,
Number 35.
oh, number 35. It should have been D. Did I not have D?
No, I mean, on the exam sheet you had D, but I was confused because,
And I said E?
well, I saw the answer for 3.
Okay, let's do it. So this is this is page 19, number 35. Okay, so what does it say? It says f is differentiable. What does differentiable mean? It means it's continuous and no sharp turns. Because you can be continuous with a sharp turn, which would make it not differentiable. Okay. Increasing. What does increasing mean? What's positive? First derivative is greater than 0 because it's increasing. And that's on the interval 0 to b. C is a number guaranteed. Okay, they're telling us mean value theorem. So what does that mean? Slope of secant equals slope of tangent, just to make sure we're aware that this is algebra 1 slope and this is derivative. Then which statement must be true? They're telling us that the function is going to be less than 0. Second derivative. What does second derivative less than 0 mean? Concave down. Does anything about a function increasing tell me that it's definitely concave down? Anything about mean value theorem that tells me concave down? So this is kind of random if you ask me. Okay. Part B says f prime of C is equal to f of b over b. Now, do you agree that looks like maybe algebra 1 slope? So let's do our algebra 1 slope. My ordered pairs are 0, f of 0, right? And then we've got b, f of b. So if I were going to do algebra 1 slope, I'd have f of b minus f of 0 all over b minus 0. Now, I agree I have b in the denominator. But is my numerator different? Yes. Now, just because I have a y value at 0 doesn't mean the only thing it could be is 0 to make it go away, correct? So there's no guarantee that f of 0 is 0. That's not interpreting that correctly. So this is not a slope of a secant line because they don't have the f of 0. 0 is not good enough. Now they're telling us that f prime of c equals 0. If the function is increasing, what is this telling me? The derivative is what? All right, always greater than 0. Is there any way for the derivative to equal 0? No. So D, now they're telling us that f prime at c is greater than 0. What does that mean? Increasing. And did we say this? Yes. Okay. F prime changes signs. Why can't if f prime of c, no, if f prime of x changes signs, what's going on? There's going to be a what? Either a maximum or a, okay, to change signs, there's either going to be a max or a min. If there's a max or a min, is it always increasing? No. So is E an answer? No. What must it be? D. Next. Yes. 80, page 80? So we're on page 80, number 12. 12. The equation of the line tangent to the curve, I think this is one, yeah. If this is the one I'm thinking of, I worked hard. Somebody else worked smart. Y equals kx plus 8 over k plus x. All right, the equation of the line tangent to the curve at x equal negative 2 is y equals x plus 4. Agreed? Can I find a y value? Let's see. This is the equation of the line tangent to the curve at x equal negative 2. What does it mean about x equal negative 2? Where is it? Is it on that function? I've got a curve. I've got a tangent line. Here's my point. So my tangent is, I got a line tangent to my curve at x equal negative 2. Is that point going to be on this line, my original function, and my tangent line? Okay, is there any way that I can use this equation to find my y, if I know x is negative 2? Why would I not want to use this one? Because I got a y, a k, and an x. So y is equal to negative 2 plus 4, which is what? 2. So I've got the ordered pair negative 2, 4. If I've got an x and I've got a y, and that's occurring on the curve, where did I get 4? I don't know. Okay, so if that point is also on the curve, this is an x, this is a y. Does this allow me to go over here? So we can say 2 is equal to negative 2k plus 8 over k, what's minus 2. Am I good? You're getting the short version. If you want to see the long version, you can listen to A Block. I did. Did you? Okay, so I'm not the only one. I did a lot of stuff. 2k minus 4 is equal to negative 2k. And actually, what I did is I set these two equations equal to each other first, and then I went to get the derivative. I eventually got there. So I'm going to add 2k, and I'm going to add 4. And what is k? 3. Is there an answer to 3, D? So what I did is I set these two equations equal to each other because the y value here is equal to the y value there. Then I said, well, the derivative of this is equal to the derivative of that. So I found this derivative, set it equal to the derivative of this, which is its slope, which is 1. And I found my x, and then I went back and I got my k. And then someone raised their hand and said, Mrs. Bride, do you think maybe we could have... Yeah. Other questions? So you got the short version. Morgan. Oh, okay. What test is it? It is examination number 4. So examination number 4. Number which one? Should be C.
Wait, so she's up for your response. Oh, that's why.
Oh, so
I don't know what.
you want a free response? So what page is this? Why don't we do a free response? So is there a certain part you can do, Morgan? Okay. Figure above shows the derivative, all right, derivative. How do we figure out where f is increasing? Where the function is, the first derivative is positive. So that would be 0 to 2 and 3 to 4. And what's the reason? Because f prime of x is greater than 0. All right, part B. For what value do we have a relative minimum? All right, if I were to draw my chart, I've got 2 and 3. From 0 to 2, I'm increasing. From 2 to 3, I'm decreasing. From 3 to 4, I'm increasing. We want a minimum. Where's the minimum? X equal 3, because f prime of 3 was 0. Was it 0? And f prime of x changes signs. All right, what about phi? Now we want a relative maximum. Where's the maximum? At x equal 2. Look at how it differs. Because f prime of 2 is what? Undefined. And f prime of x what? Changes signs. Did I ask you for D? Oh, I could have. I didn't ask you for D? Oh, well, if I didn't specify, then I need D. Let's draw the picture. You all can do this. This was on your last test.
You did specify. Just kidding. I did it. I forgot about it.
Oh, okay. So I did say that?
Yeah.
Okay. So what are we supposed to be doing? First of all, they said we were starting at 1, 1, correct? 1, 1, yes? Use your answers to graphs from 1 to 4. So what should I do to get from 1 to 2? I should be increasing concave down, increasing concave down. To get from 2 to 3, I should be decreasing concave up. To get from, 3 to 4, I should be increasing concave up, increasing concave up. Yeah. Because if there's a break. It's not continuous. All right, everything's online.